I'm Mark Coleman. I run a family business, an Irish business out of Birmingham. We operate across the UK and beyond. And I'm a proud member of the Chartered Institute of Building and proud to be a Chartered Institute of Building chartered company as well.
Hi everyone, my name is Titus Akpan. I'm an assistant project manager here at Coleman. Have been championing the sustainability agenda for the business, and I'm also a CIOB sustainability ambassador.
Okay, so just a bit about me. I'm a fellow of the Chartered Institute of Building. I'm a member of the Institute of Demolition Engineers, and I'm an associate of the Institute of Explosive Engineers. I have been at Coleman's for 32 years. The business has been trading for 63. As mentioned previously, we're an Irish-run business, Irish family business, and we specialise in work across the UK and beyond. And really what our focus is, what we're talking about here today, is engineered deconstruction. That's what we do. We see the problems around the world, in Valencia, Florida, and even in the UK. What happens in the environment is really having a massive impact on us personally, as businesses and as a world. We're very focused on it, and you can see here that there are a number of initiatives that we have in place to help us deliver our objectives as part of Coleman's, but also as part of the wider construction industry. This is part of our brand work, which we did. It was very interesting. We asked 15 of our clients that we'd had relationships with in a cumulative total of 289 years. And from a heat density map, from all of the transcripts from the interviews that we took, these were the key words that came out of the research that we carried out, that we are trusted, we're honest, provide quality, and our people are of the highest standard. We believe that delivering change or evolving, we are heavily dependent on our people, and therefore culture in our businesses and the working environment is absolutely critical. So we have to look after people, we have to invest in people, we have to make sure that we don't abuse them, provide a caring community, and bringing new energy and ideas into our industry to help us achieve our common objectives, which is to win as far as carbon reduction is concerned. So to put this together and indeed feed into our business strategy, we are closely associated with these organisations, the Chartered Institute of Building, the Royal Institute of Chartered Surveyors, the National Federation of Demolition Contractors, the European Demolition Association. We're seen as leaders in the industry amongst many others, but we're recognised as such. We've done work online. We're linked with a number of universities, and we're also involved with a few leading hydrogen and carbon reduction initiatives. So when we talk about demolition and we compare that to engineered deconstruction, there are differences that we'll be talking about today. We see demolition having the chain and ball still. That has changed a lot over the years. But now with the need for us to extract materials and reduce carbon, the way that we carry out the work is focused on removing those materials whole rather than reprocessing them and recycling them. Lots of companies are under pressure in terms of their ESG goals and to reduce the embodied carbon. It's true that this is relatively new, and therefore a lot of companies, including ourselves, are struggling and find it difficult to understand how we can actually have an impact. So we're hoping that our experience will help people understand that and give them support through this journey. So why is it important? It used to be health and safety that was agenda item number one. We now see virtually every meeting that we have, it's about the environment. A lot of the waste comes from the construction industry, and within the construction industry, we have 30 or 40% of that emissions from the energy that's required is produced in steel, concrete and cement. So why must the industry change? Construction develops or generates the most waste. It's the largest waste stream by weight. Recycling is great, and we've come a long way, but it means that we lose the value of the materials as they are. The scrapping of materials and the recycling of materials destroys the embodied carbon. Reusing the material significantly saves that carbon and allows it to be introduced into the new construction effectively. So last year, our past president for the CIOB, he was focused on the United Nations Sustainable Development Goals and the impact that our culture has on the environment. And this is a global initiative where we are focused together on how we can help our environment, the people that we live with, to provide a safer and more healthy way to live our lives. So we picked out some here that are relevant to us, 9, 11, 12 and 13. And you can read on the screen there, we've got the ability to use technology in 9. Sustainable cities and communities, this is probably the most relevant one. Reuse keeps values in cities rather than exporting waste streams. Responsible consumption, making sure that we're not wasting the resources that we have, and in turn then protecting the environment by ensuring that the embodied carbon is saved and is not wasted, generating more carbon back into the environment, which has a huge impact on virtually everything around us. We've seen that there's global momentum in America, North America, Portland and Vancouver. It's mandated now that deconstruction is the way to go rather than demolishing. The Netherlands we see as probably the leading country, certainly in Europe, which is focused on circular economy, materials passport, material reuse. And France has introduced EPRs, which is extended producer responsibility, where when the materials are specified, there's also an end-of-life strategy for what happens to them once they're no longer required in their current format. So when we talk about engineered deconstruction, we are literally talking about reverse order of construction. We're talking about an engineering-led strategy where we see the materials as urban quarries, not as waste. We use technology. Titus will talk about that a little bit more later. And we are aiming to remove as much of the structure as it is, rather than to change its constituent parts. So it's a shift from demolishing and recycling to identifying, recovering and reusing. So the key benefits, as we see it, are that we feed well into the circular economy, it diversifies our business, and it helps all of us meet our targets and objectives. The activities that we carry out focus less on the use of gravity, which historically has been demolition's best friend, and prioritises on material value. And to do that, we have to assess the structures structurally. In doing so, because it's an engineer-led focus, what we find is that the safety and quality of the outcome before, during and after is of a far higher standard than what we've historically been used to. We get more value out of the materials and therefore save project costs, and we're able to introduce innovation and technology into our processes and procedures. So unlocking the value, we are able to stop taking material, particularly with steel, which is the focus here, is that historically we scrap material, we cut it into short lengths, we load it onto trucks, it goes to a port, gets shipped abroad, smelted down, reprocessed and brought back. That is hugely energy wasteful. It's not smart, and there are better ways of working. And having said that, this is not a new thing for the demolition industry, but it is something that lost its focus and is now something that we're trying to bring back in and people to focus on. It allows us to de-risk the projects because it's an engineering-led process. We're able to actually assess what we're doing and have good collaboration in amongst the design team. And as I said, the operational efficiency, we found that the work is better planned, it's slicker, and the program is more deliverable, and the objectives and the outcomes are closer matched. We always get asked, okay, what impact does this have? We do need to be involved a lot earlier in the process. We find that if we're not, the steel don't fit the design, they may be too big. There has to be early engagement. We need to have visibility of what the outcome is, what the requirements are for the project, so we can match what the steel work is going to be but there needs to be a bit of flexibility because some of that steel work may actually influence the design. We look to inform the planning process and the procurement and deliver within the sustainability strategy. Keep repeating this point. This is one of the most important points about early engagement. If we're not involved early, we lose the potential to add this value. In doing so, we're aligned with the Chartered Institute of Building around the quality, competence, and delivery in terms of digital and sustainability. We're aligned with the British Standards Institute, where they have really good guidance on reuse testing and assurance, which our procedures follow. The design in terms of engineered deconstruction works really well with circular procurement. And what it allows us to do is position what we're doing as a new way of working. And hopefully we can collaborate with the wider industry as we do and all share our knowledge and experience and accelerate this process and deliver it in a better way for the future.
At Coleman, we are keen at delivering to our clients and our stakeholders what we say we can do. So we've practically engaged the methodologies of engineered deconstruction and on our jobs, and this has helped us to be able to contribute to the ESG goals for our client. Just a few steps to highlight, a few key steps to highlight. So we, through digital scanning, 3D digital scanning, we've been able to create a digital twin technology of these buildings, for instance, and that has helped us to provide and produce verified inventory of every material, say for instance, steel in that building. And we've also been able to carry out resource audit, or what we call pre-demolition audit. So this helps us to be able to identify materials which could be recovered, which are viable for reuse. And this then leads to our engineering team then having an engineered sequence on how this building or this structure or facility can be deconstructed. And then these materials, once we've taken it down, then goes into a rigorous process of testing, recertification, and then we have a material passport that follows that. So at the back of this, our business is Emerald Steel, which is a low carbon structural steel initiative, which we've brought into the business to support our client. Just recently at one of our projects, we've been able to dismantle a large bottle frame building and save a good amount of steel from that building. And we were able to hand that over to the client, which then went into the new build. Just like Mark has said, the key thing for this process for engineered deconstruction, which we are talking about today, is early engagement. This gives us the opportunity to engage and collaborate with the design team to bring in these materials into their plan. It's also important to say this also helps us, for instance, with the steels. If what we've had through our inventory is not able to fit into the design, there is an ample opportunity to look at the steel members, and the design engineers can then see how this can fit. We then have the digital mapping system through 3D scanning and point cloud evaluation, which helps us to then transform this scanning data into a 3D drawing. So what the 3D drawing does, which I'm going to also talk about in the next slide, is to give a clear representation of what the building is. We are then able to identify on these drawings what material or what steel is suitable for reuse. And then we then get all this data together, prepare an inventory or steel takeoff, which we then issue to the client. And then this is then verified through the British Standard Steels data sheet to make sure that all the materials, all the steels we've taken down or we've identified in that project or that building meets the standard. On this slide, you could see a clear, there is a physical verification of every material that comes down from the building. You could see on the top right-hand side, that is an in situ hardness testing, which we have to do on every material just to make sure it meets the standard. And in terms of storage and how we actually, when we've taken this down, we've put the materials in such a way that we do not tamper with the material's integrity. You could imagine a situation where materials or steels are being moved about the job, damages to the flanges or to the web, but through our sequencing and our engineering planning, we've been able to make sure that these materials are stored properly. This is a typical example of the point cloud data that we get from digital scanning. This, like I said, this then transforms into softwares like Revit. We are then able to produce a 3D model drawing that identifies what steel is there, what section sizes, the profiles. We as well put up color codes just to make things easy and presentable. Like what you see now, the green color shows this steel is salvageable or is reusable. And then this then transmits to the guys on site who then look at this and are able to identify this physically on the job. This is also a typical example of the inventory or the stocks we take from careful scanning, modeling. We then produce all this. And like I said, it forms part of the material passport at the end of the job, which we then hand over to the client or whoever we are working with. So from a carbon lens perspective, we are all aware producing new steel or virgin steel represents highest embodied carbon. Recycling then drops down a bit, but if you look at the process of recycling, it's still energy intensive, which is not the best. But then when you look at reuse, it is a more sustainable path to take. So this takes off remelting that material or steel, remanufacturing it, and then it reduces the transport emissions. For us, one of the things that we've tried to consider in terms of transport, so across the country, we have hubs close to where we work, so we don't necessarily have to transport these materials long distance. So we try to make sure all that fits into the carbon reduction we are talking about. So materials are then moved into hubs not far from the job, and that reduces, when you've done the carbon accounting, it reduces that data of carbon emission. Thank you. So this is the project I was talking about earlier. It was a 90,000 square meter quarter frame building in South Wales, which we deconstructed for one of our clients. We had 3D scanning done on that job, and then that then produced the BIM models, 3D modeling for our client. And then with this model, we were able to assess 4,500 tons of structural steels, which were physically identified on the job for reuse. In terms of efficiency, 89% of these steels were removed, taken off site, refabricated, and then put back into the building for reuse. 600 tons were clearly repurposed for the new build. And then that way we were able to save about 6,700 tons of carbon compared to using new steels on the job. So comparing traditional demolition with deconstruction, the bigger picture is embodied carbon savings. So the true value of deconstruction is found in the reuse of structural materials. Just taking a cue from the job I've just talked about, on site, we were able to reuse over 600 tons of steels. And then from that same job, we reintroduced over 5,000 tons of structural steel into the market through our supply chain and different stakeholders we work with. And that was an additional 9,000 tons of carbon saving. And then through fuel optimization, across our fleet as a business, by opting for HVOs, instead of standard diesel, we've been able to achieve about 60 tons of carbon saving from that as well. So you could see we are not just talking about engineered deconstruction, but we've tried to bring that as a core practice in our business. Also, as a business, in the last 3 years. If you look on the chart displayed on the screen, in 2023, we were able to repurpose about 128 tons of steel, but that has progressed to about 1,700 tons at the end of last year. So we've been able to, over the years, bring this into the core of what we do in Coleman's, and just to show to everyone, our stakeholders, to our clients, that this is what we say we can do, and this is what we've done. These are the benefits, just like Mark said earlier, and then that opens up even more opportunities for everyone. So the embodied carbon savings per ton, as we all know, for virgin steel is about 1.9 tons. For recycled steels is 1.5. But if you look at repurpose, that has dropped drastically. So it's an average of about 0.07 tons of embodied carbon for repurposed steel. So the key success for us, practically, for this scheme for Emerald Steel and Deconstruction is early involvement. So Mark has said that before, and this is key. It is vital. It is critical. Early involvement is essential to engineering reuse of materials. If we need to have that efficiency, we have to be involved at the start of the job. That would then lead to the design team buying into the idea or the plan, because most of the times you could have people sitting back to say, is this viable? Can we go on? But when we get involved from the start, that gives everyone in the room ample opportunities to talk about this, look at the benefits and how we can get things moving forward. Talking about designs, technologies. So we've used different technologies to make sure that we get the right data. Rigorous management of these processes will ensure safety and quality standards as well. And then this will also lead to a rapid and proven model for circular construction within our industry. So the video you're about to watch is a high-level summary of this project I'm just talking about.
So for this project, we were on site with a global tech giant, and we looked at the project and we said, look, are you thinking about reusing this steel? And they said, no, it's too risky for us. So what we set about doing is taking 2 sites that we're working on in London and doing a proof of concept. And what you've seen is us taking down the material, re-engineering the material, repurposing it, and documenting each and every step of what we were doing and demonstrating, but also learning along the way to make sure that we could comply with what they called the nuclear standard. We had to build, if we were going to repurpose this material, to comply with nuclear standards, which is the highest construction regime that we're aware of. And we took the buildings down, we repurposed them. We're doing a wellbeing project in southwest Kerry in Ireland, and we went as far as actually putting the structure up, building the building, documenting everything, and making sure that we were then able to talk to our client from a position of authority and experience and say, look, this is what we've done. We've listened to you. You're concerned about the risk. This is how we've been through the process. This is the learnings that we've achieved. And we really do believe that there's a huge carbon saving to be made on your project by allowing us to deconstruct the material, wholemeal, piecemeal, re-engineer it, take it through all the quality standards, and then reincorporate it, reintroduce it into the new construction of your data center. You'll see here that this is the new steel. When I say new steel, repurposed new steel. And this is the site here in Ireland where we're shipped it over there. It is the only project that we've got where we're actually able to reconstruct. As you can appreciate, that may be difficult. just to find a site where you can put it up. But whilst there was some carbon impact on transporting the material, we did do it as a backload and made sure that the transport was efficient. It then led into this huge tonnage of carbon saved on this project, which is the site that we're working on down in South Wales. You'll see that this is a typical portal frame building, one which we can all recognise. This is the deconstruction process, and as you can see, it's very clean. It doesn't really look like a demolition job. Steels are being dismantled. Loaded up, and the re-engineering, again with the carbon footprint in mind, was carried out by a local supply chain manufacturer and engineering company. So we always get asked, does it cost more money? Will it add more time to the program? And the answer is, if it's considered late, yes, it will. But if it's brought into the design early, it won't. It will be more dependable. You will realise the carbon savings. And in our opinion, you have a safer, slicker way of working. The cost per element can be more, but that has to be adjusted against the cost of the new steel. It's program neutral. We've not found that it takes any longer. And the big win here is that not only are we doing the right thing, but it's helping clients achieve planning permission. It's helping big organisations that have to submit data on their carbon footprint reduce their carbon footprint. So we mitigate the risks by it being engineered, tagging all the materials, engineering the solutions, and designing our mythologies around that. So it's absolutely crucial that we all learn, right, and we all collaborate. And to do that, we don't just do it with our clients and our supply chain, we explore the market, but we also engage with universities, and we're involved in multiple PhD projects, along with knowledge transfer partnerships, where we're actually investing in innovation and research and development. So it's really good because it brings the team together. We're all aligned around the right thing to do. We're all planning. We're all informed. We're all communicating. We're able to invest in innovation and technology. It gives better predictable outcomes and reduces client exposure, and we're managing expectations from the onset. So how we see this evolving is clearly technology is a massive part of it. Automated materials inventories using AI to work with the scans that we take out on site. Standardizing materials passports and digital product identities, focusing really on the quality process. So the removal is key, so we minimize damage, the testing to ensure that it is fit for purpose, and then the time that's needed to re-engineer it into the project. Our next focus is on timber. So we've got a number of jobs where we're now taking timber beams, joists and the likes out, and we're looking at how we can repurpose and re-engineer the timber. Maybe it's glue, lam beams, the likes. We've seen big movements in terms of reuse of facades, glazing systems, M&E plant and equipment. Historically, a lot of that would be scrapped. We now have our own eBay marketplace page, Green Market Solutions, where we go through and we post everything that we've got on the projects. And it's really, really surprising what will move. It's not necessarily commercially better, but it's definitely more environmentally friendly. And then, of course, the use of modular and temporary structures designed for redeployment. So actually looking at something and saying, okay, what can we use that for? And typically a lot of the steel that we're repurposing, we're now introducing into secondary use for temporary and permanent works. We really believe that demolishing buildings creates more waste than what it needs to, and that deconstruction is the way that we create an asset that is able for us to save carbon being emitted into the atmosphere. So we're shifting from niche recovery to a standard material supply chain. The supply chain is absolutely crucial to what we do. You've seen the work that we're doing with the digital twins. That feeds into a digital footprint that works really well with materials passports. And we are really focused on establishing engineered deconstruction as the primary method within the demolition sector for decarbonation of our industry. There are other wider benefits. Of course, it's good for our planet. I've got 3 kids. They're now grown up, but I look at the life that they're going to live in the future, and that's important to me, what happens to them and indeed their children. It does reduce long-term costs. There is grant funding available and private investment initiatives, reducing our tax bill via research and development. It's really good for the culture of the industry and the people that we employ and attracting new talent. And we believe that with carbon taxes coming in the same way cigarettes that are bad for your health, the smoke that comes out of it, it's the same as what we do in our industry. And with this tax coming, it's going to be a heavy burden to us. And we believe that carbon conscious companies, it's not just about doing the right thing, it's about winning in business. Now, this is a bike that we found on a project, and we've got 2 of them, 70-year-old bikes. You can still see the pump on the side there. And we basically refurbished them, but we linked it into social value. So we're doing a project with a big university. They got lots of bikes buzzing around. We went in and we put in a service station. Guys came, we serviced their bikes, and while they were doing that, they buzzed around on our bikes in the university. It helped raise the profile of what we're doing. We put QR codes onto it, and the feedback that we had from the university and the students was really fantastic. And that's just an example of the way that we can work hand in hand with doing the right thing, reducing carbon, being efficient, being business motivated, but also tie it into social value. And we've done other things with football teams and boxing clubs and schools and all various types of initiatives. So we can do a lot more. It's just a case of us thinking about it, putting the time and effort into it, and planning it for our future. So what we're finding is that the cost for removing the steel is 20% more than traditional demolition methods. In terms of the whole project, it's negligible because there are still other activities that we have to carry out on site. But the benefits come later on down in terms of the project, in terms of we are able to add value into the outcome of the design and provide an efficient way of working, which is good for the environment. So cost-wise, we would say it's neutral, but it's a bit like when you have a HD TV, 20 years ago, it was thousands, whereas now it's hundreds. And the more people that do it, the better we will become, and we'll be able to drive that cost base down. Of course, it's all dependent on the structure. Historically, demolition contractors would always take the slate off, take the timber off, chip the bricks. As construction changed and became more composite and difficult to split and segregate, mainly because of thermal reasons, bizarrely, that's the thing that's had the impact on us being able to reuse the materials in their form. But yeah, every project's different. And we just really urge people to think about the project that they've got as an asset and not see demolition as a waste stream, but as an urban quarry where they can look at it and say, okay, what can we do with this? How can we reuse this material? And when you focus on it, it's surprising how long that list can be.
For every material we've identified for recovery, so there is a rigorous testing process that goes into it. Most of the time, just to start things off, we do carry out in situ hardness testing, like the steels we're talking about. So, and then these materials then there's an extraction that is done on every piece of steel. That then goes into the lab for lab testing. All the chemical analysis, mechanical analysis is done in that lab. And then we then have a report that shows to the client or shows to anyone that this material is fit for reuse, the result or the data we get from all the testing is checked against the standard. So we are not just hooking up values, or it's not just from the moon. So everything is being checked against the standard, and then that then produces a certificate for every piece of steel that is then issued to the client.
So the insurance costs, no, it's specifically around the quality. So following procedures, developing systems that deliver quality against the requirements. So the requirements of new steel is exactly the same for repurposed steel. So whatever you look for, and this applies to timber or anything, whatever you look for as a reused material, the testing, the certification is all the same. It still has to comply with that. So as far as insurance is concerned, it's exactly the same cost. What we found was that in the early stages, it was not being involved early enough. And once we were involved earlier, we were able to plan better. And a lot of the time, what we find is that we're too late in the thinking, and our needs aren't actually facilitated within the program. By introducing us early, we're able to say, we need this space, we're going to work through it in this direction. And maybe the client turns around and says, well, that doesn't work for us. We want to get piling rigs over here and away in that area. So we can re-engineer the program and the methodology, the sequence to suit. So the early engagement is probably the most important part of the process once everybody's agreed that materials reuse is the way that this project wants to go. Yeah, we do. And they're in various stages. Some are quite mature. So steel is a quite mature area in terms of it's always been done, but now it's been reintroduced. Reusing concrete in its form is more difficult, but there are projects on the way, one of which we're involved with Aston University, which is a PhD. It's more difficult to reuse concrete in its current state. But yeah, sheeting, lighting, M&E equipment, plant and equipment, there's a whole variety of things that can be reused, not least just furniture when you first get into a building. And that's where we try and work with the local charities, and whether it's a pool table or chairs or furniture, we try and work with those guys and say, look, we've got this. Does this help you with what you're trying to do? It's not. It's just a case of making sure that it's thought about early enough. And that's probably our key message here. Deciding that you want to reuse material, great, get involved and plan for it early, because without that, you end up wasting the ability to reuse it and achieve the carbon savings. So you'll have seen that on some of the images there, we've got propping. It's like anything. You build a building and you need to use temporary works to put it up. To take it down in an engineered deconstruction environment, you need to use temporary works to take it down. We are moving more and more towards then that the temporary works are actually repurposed steel as well. So there are many benefits, and we've used temporary works from a project which we're deconstructing, engineered them for temporary works, and then removed them as temporary works, and then reused them for emerald steel for construction in another project.
The main one for me is early engagement, when we are not brought into the scene at the start. One of the things in that environment is the buying in. So you have round the table, not everyone buying into the idea. So when that happens, it delays the process, and then that could also affect or impact on the program. So that, for me, in the last couple of years, has been one of the key challenges. So like Mark had said, that early conversation or early engagement could mitigate this kind of challenge. So everyone gets the picture, everyone understands the story, and then buys into it. So that makes things a lot easier for us.
And that also applies to the guys on site, because if they're not bought into it, They want to get the machines in and scrap the material. And if they're then not focused on the right outcomes, we've seen in the early stages that the amount of damage that occurs means that the reuse of the material then is rendered useless. So the proportion of what we took down to reuse, 20% of it couldn't be reused. We've now got that down to a couple of percent.